Welcome to another episode of AI 10X, brought to you by 10 Leaves.
Glad to be here for this one.
Yeah, it's going to be a good one.
Yeah.
Whether you are prepping for a major strategy meeting or trying to map out these rapid tech shifts, or you're just insanely curious about where the architecture of our future is heading, you are definitely in the right place.
Absolutely.
You asked us to look into how artificial intelligence is shifting the accessibility landscape. And today's deep dive is designed to be your custom-tailored shortcut to being well-informed on a topic that is, quite honestly, quietly rewiring human existence.
Rewiring is the perfect word for it.
Right. So we are analyzing a deeply insightful excerpt today from a piece titled AI 10X, Inclusive Innovation and Digital Accessibility. And the core mission for our discussion right now is exploring the really profound question of how AI is empowering people with disabilities and how it's making technology more inclusive than ever before.
And, jumping right in, it is crucial to establish right from the start that what makes the source material so powerful isn't just the underlying tech. I mean, it's not just about the neural networks or the sheer computational power.
Right. It's bigger than that.
It is a massive paradigm shift for human independence. We are looking way beyond incremental software updates or, convenient little consumer gadgets.
Yeah, completely.
We are analyzing a fundamental redefinition of what it means for an individual to navigate their life, their career, their physical environment with complete autonomy. It's about abstracting away these legacy barriers that have persisted for, well, centuries, really.
Okay, let's unpack this because the source text anchors this paradigm shift around 4 distinct AI technologies. Let's start with the first 2, which effectively build what I view as this ultimate communication bridge. We're talking about speech recognition and real-time translation. And when we look at this through the lens of a professional, we really have to move past the basic idea of just using voice to set a kitchen timer.
Oh, definitely.
We are talking about replacing legacy hardware inputs that has historically bottlenecked human potential.
What's fascinating here is how these specific natural language processing models transform from just being operational conveniences into vital lifelines. I mean, non-negotiable infrastructure. Let's evaluate speech recognition through the lens of input friction.
Okay, lay that out for us.
So for a user without motor limitations, interfacing with a QWERTY keyboard or tapping a glass screen is a secondary, almost subconscious reflex.
Right. You don't even think about it. You just type.
Exactly. But that standard hardware interface is actually a completely arbitrary biological bottleneck. If a user has a motor disability, that standard hardware becomes a rigid, impenetrable wall. The intellectual intent to execute a command is fully formed in their mind.
But they just can't physically pass it through the bottleneck.
Right. The biological telemetry required to push that intent through traditional hardware is interrupted. Speech recognition models bypass that physical prerequisite entirely. Think of it like a universal key that instantly unlocks the digital world for those who cannot use traditional inputs.
A universal key. I love that analogy.
Yeah, it maps vocal intent directly to digital execution. The AI absorbs the unstructured acoustic data, it parses all the contextual nuances, the industry-specific syntax, even the ambient noise in the room, and it translates those sound waves into the exact digital inputs that previously demanded 10 highly dexterous fingers.
The compounding effect of bypassing that hardware bottleneck is just massive. I want you, our listener, to really imagine navigating your highly demanding professional environment where your voice is your primary physical tool.
Imagine writing code that way.
Exactly. Compiling complex code architecture or drafting intricate legal briefs, where vocalization is all you have. If the speech recognition suffers from high latency or it just doesn't understand context, your productivity is artificially throttled.
It's incredibly frustrating.
But when that AI layer operates flawlessly, when it abstracts away the need for mechanical input, you are instantly operating at the exact same velocity as anyone else in your field.
The physical impairment is rendered completely irrelevant to your digital output.
Irrelevant. And that conceptual framework transitions perfectly into the second technology the source highlights, which is real-time translation. Because the speech recognition solves the outbound input problem.
Real-time translation is solving the inbound latency problem.
Yes.
It is the critical inverse of the communication bridge. While speech models map intent to execution, real-time translation models neutralize the sensory and cognitive latency when receiving information. Imagine a professional who is deaf or hard of hearing, and they are embedded in a rapid-fire, highly synchronous board meeting. Historically, that scenario required a human interpreter.
Which inherently introduces a processing lag.
Exactly. The flow of information is bottlenecked by the speed of human translation. That isolates the individual from the immediate synchronous rhythm of the room's dynamic.
They are essentially operating on a delayed data stream while everyone else is laughing at a joke in real time.
Precisely.
And the friction there isn't just about missing words. It is about missing the spontaneous micro-interactions that actually define human collaboration.
And that is exactly where the AI models step in to eliminate that specific latency. Advanced real-time translation systems ingest overlapping audio streams, contextualize the vocabulary on the fly, and instantly output parallel data streams.
Like highly accurate text on a localized screen.
Right, or even an augmented reality display. And conversely, it can take specialized shorthand inputs from a user and render them into perfectly synthesized, natural-sounding speech for the rest of the room. It breaks down immediate barriers to communication and inclusion.
It ensures the data transfer rate of the conversation never outpaces an individual's sensory ability to ingest it.
It keeps the user embedded in the absolute present moment of the interaction.
Here's where it gets really interesting, because the source material doesn't limit this analysis to just the digital or conversational spheres.
No, it goes much further.
It does. We move from navigating abstract data structures to navigating the highly unstructured, chaotic environment of the tangible physical world. The next two technological pillars the source brings up are computer vision and assistive robotics.
This is where we watch AI step out of the server rack and become a real-time physical interface.
Right, AI acting as a localized edge computing sensor for human beings.
Let's examine computer vision in this context. For a user who is visually impaired, the physical world is this constantly shifting matrix of unstructured visual data.
It's chaotic.
Highly chaotic. A dynamically updating transit schedule, an unexpected construction barrier on a sidewalk, the shifting geometry of a crowded room. Navigating that matrix historically required human assistance, a guide animal, or just immense cognitive load dedicated to spatial memorization.
Which inherently restricts spontaneity. You can master a known road, sure,
Yeah.
but an unknown dynamic environment presents immediate, unquantifiable variables.
And computer vision completely alters that navigational equation. We aren't talking about simple object detection here. We are talking about real-time semantic rendering of a three-dimensional space. The AI system acts as an interpretive set of eyes.
An interpretive set of eyes.
Yes. Utilizing portable optics, it actively analyzes the geometry, the depth, the contextual semantics of the physical environment. It has to instantly distinguish between a harmless shadow and a dangerous pothole.
Or read the specific dosage instructions on a curved, highly reflective medication bottle.
Exactly. It absorbs the chaotic visual data, processes the risk and relevance, and synthesizes it into an auditory or haptic data stream that the user can instantly comprehend.
So the AI is essentially performing the massive parallel processing required to understand spatial geometry, which is the exact processing the biological visual cortex would normally handle.
Precisely. And then it routes that finalized intelligence through an alternative sensory pathway.
The AI bridges the sensory gap.
It acts as the ultimate bridge.
And when we look at the source's inclusion of assistive robotics, we see the technology bridging the physical gap too. If computer vision provides the localized intelligence, assistive robotics provides the alternative physical chassis.
And to really understand that, we need to look at the philosophy of the relationship between human neurological intent and physical execution.
Right.
Every physical action, reaching for a heavy object, adjusting a workspace, navigating terrain, it all begins as a highly specific electrical signal in the motor cortex.
The intent.
The intent. For individuals with severe physical disabilities, that neurological intent is sharp, clear, and perfectly formulated.
But the biological machinery required to execute the intent is compromised.
Exactly. Assistive robotics steps into that void to grant physical autonomy. The AI serves as the critical middleware layer between the human brain and the robotic hardware.
The human provides the strategic command, and the AI handles the complex tactical execution.
It takes a viable input from the user, which might be a highly subtle facial movement, a specific vocalization, or even raw eye-tracking telemetry, and it translates that singular human intent into the incredibly complex multi-joint articulation of a robotic prosthesis or a mobility device.
The user thinks, I need to manipulate that object.
And the AI instantaneously calculates the necessary spatial awareness, the inverse kinematics, the required grip torque, the trajectory to safely directly execute the command. It restores the sovereignty of human intent. It completely abstracts away the physical limitation.
The limitation is offloaded to the hardware. That is a brilliant reframing of the human-machine relationship. And it leads us directly into the macroeconomic and societal implications detailed in our source material.
The ripple effect.
Yes, the ripple effect. We have clearly established the technological mechanics, the speech, translation, vision, and robotics, but the source explicitly shifts the focus to the broader impacts.
If we connect this to the bigger picture, the narrative naturally evolves from what the tech is to why it matters.
Right.
The source identifies 3 highly specific societal outcomes driven by this technological integration: greater independence, comprehensive inclusion, and aggressive participation in work and society.
Taking that first outcome, greater independence, it really requires us to look beyond just the convenience of the technology. Independence in this specific context is about the total restoration of personal privacy and spontaneous autonomy.
Absolutely.
We frequently overlook the sheer cognitive and emotional fatigue associated with having to constantly coordinate your daily survival with the schedules of external human caregivers or interpreters.
It is the elimination of logistical dependency. When a localized computer vision model allows a user to read their own highly sensitive financial documents in total privacy without a sighted person in the room.
That's huge.
Or when an AI-driven assistive robot allows an individual to feed themselves without requiring coordination with another person, we are looking at a restoration of profound human dignity. It provides the user with the absolute power to dictate the terms, the timing, and the privacy of their interaction with the world.
Which serves as the foundational bedrock for the second outcome: inclusion. And I noticed the source is exceptionally deliberate in its use of this term. It strips away the superficial corporate buzzword layer of inclusion and defines it as a functional operational state.
Functional inclusion means the complete absence of environmental fiction.
Right.
It is not merely about ensuring an individual has physical access to a room. It is about guaranteeing they possess the exact technological infrastructure required to seamlessly influence the dynamic inside that room.
True inclusion occurs when the environment no longer artificially highlights a user's limitations.
Exactly. When an AI translation layer operates so silently and efficiently in the background that a neurodivergent user or a user with a hearing impairment can fluidly participate in a high-stakes brainstorming session without breaking the group's momentum, that is the operational definition of inclusion.
The technology absorbs the friction so the human doesn't have to. And the economic corollary to that frictionless interaction brings us to the third pillar listed in the source, which just marvels me: participation in work and society.
It's massive.
The macroeconomic implications of leveling the playing field in the workplace are genuinely staggering. For centuries, our foundational definition of productive labor was rigidly tied to specific physical interfaces.
The layout of an industrial factory or the standardized hardware of a modern corporate cubicle?
Yes, the infrastructure of commerce was physically exclusionary. And society has lost out on so much talent because of that. We are talking about brilliant strategic thinkers, elite software architects, and creative problem solvers who have been systematically sidelined from the global economy.
Marginalized not because they lacked the cognitive horsepower,
Right.
but simply because their bodies were incompatible with legacy input devices or standardized office geometry.
And AI is actively dismantling that legacy architecture. By integrating these tools, we are watching the physical barriers to market entry just evaporate. Society finally gets to benefit from this massive reservoir of talent and perspective that was trapped behind sensory or motor firewalls.
If your primary economic output is analyzing complex data sets, and AI allows you to manipulate that data via highly advanced eye-tracking telemetry at the exact same velocity as a colleague using a mechanical mouse, your physical disability ceases to be a professional liability.
It fundamentally alters the wealth generation trajectory for millions of individuals.
It does. Participation in the workforce is the primary vehicle for achieving long-term financial independence. By deploying AI to empower people with disabilities, the technology is actively dismantling historical cycles of systemic underemployment.
So what does this all mean? We have mapped out the sophisticated edge computing tools. We have analyzed the profound societal shifts. But the source material leaves us with one final critical point regarding the future of software and hardware architecture: the design priority. Yes. It notes that accessibility is rapidly transitioning into a primary design priority.
And the crucial insight here is that accessibility is moving from being an afterthought to a core feature. And the source specifically emphasizes that AI is the catalyst accelerating that shift.
Right, because historically, building accessible technology was basically an exercise in retrofitting.
Accessibility was treated as a patch.
Exactly a patch. A clunky, resource-intensive add-on deployed long after the core architecture was already finalized.
It was a system built for the mythical, statistical, average user, and anyone who fell outside of that narrow biometric parameter was handed a bolted-on, suboptimal workaround.
Here was a rigid system, we added a ramp to the back end. Just adapt yourself to fit our constraints.
Exactly. But the paradigm shift the source is highlighting moves accessibility away from the margins and places it at the very core of the foundational design logic.
This raises an important question, though. I want you to consider how AI actually makes this possible. How do you successfully architect a single, unified system that works flawlessly for every single human being when human needs are infinitely variable?
In the era of hard-coded legacy software, you simply couldn't. It was financially and computationally impossible to build a million bespoke user interfaces, so developers compromised. But AI fundamentally changes the computational math by introducing dynamic adaptability.
Meaning the software architecture becomes fluid.
Exactly. It ceases to be a static environment. Developers no longer have to meticulously hard-code every conceivable accessibility permutation. Instead, they architect a core functional logic, and the AI serves as an intelligent, personalized rendering layer that learns and adapts to the specific user in real time.
So it adapts to the user rather than forcing the user to adapt to the system.
Exactly. If the AI detects that a user is navigating a complex dashboard using a screen reader, the system can autonomously strip out unnecessary visual clutter and prioritize auditory navigation. It inverts the historical power dynamic.
The system utilizes localized intelligence to instantly figure out the user's specific capabilities and then dynamically morphs its own architecture to perfectly fit the human's needs.
It is the absolute pinnacle of personalized technological infrastructure. And because AI handles this dynamic adaptation so seamlessly, it aggressively removes the friction for the developers themselves. It becomes cost-effective to deploy universally accessible products from day one.
To synthesize the ultimate takeaway from the deeply profound excerpts we've been analyzing today, artificial intelligence possesses the absolute power to make the technological landscape more universally inclusive than ever before.
Without a doubt.
We have dissected how advanced real-time translation and speech models build vital bridges. We have explored how computer vision and assistive robotics grant unprecedented physical autonomy. And we have analyzed the massive ripple effects, true inclusion, and unlocking brilliant human capital within the global workforce.
We are witnessing the death of designing for the statistical average human.
Which leaves you, our listener, with a final, highly provocative thought to mull over on your own. We've spent this time dissecting how AI serves as the ultimate middleware, bridging the gap between a person's physical limitations and the unyielding world around them. But follow this technological trajectory to its absolute logical conclusion. If artificial intelligence eventually reaches a point where it can perfectly, instantly, and seamlessly adapt both the physical and digital world to flawlessly fit every single individual's completely unique needs, will the very concept of a disability completely change its meaning in the future?
It's a profound question.
If the highly responsive environment adapts so flawlessly that the barrier entirely disappears, does the disability effectively cease to exist in any functional sense? It is a fascinating, potentially utopian future to model. Thanks for joining us for another episode of AI 10X, brought to you by 10 Leaves.